This is Mrs. Palmer-Quay with the third video for Module 1. In this video I want to talk about calculating with significant figures and how to round off correctly, and scientific notation. Just a quick review. Remember, significant figures include all the digits that you are certain of in your measurement, plus one uncertain or estimated digit. Any non-zero digit is significant. The zeros are the tricky ones. They're significant if they're between two non-zero digits, or they are right-end zeros in a number that has a decimal point. Zeros are not significant if they are left-end zeros. If it's 0.006, these three zeros actually are all not significant. Or if they are right-end zeros without a decimal point, as in a measurement of 200. We only have one significant figure in that number. So when you are working in your lab experiments or the questions you have to answer in the textbook, you're going to be asked to do calculations, and you need to express the answers to your calculations in significant figures. Most of us are going to be using calculators, either scientific calculators or the calculator on your phone. And these can give you very precise results in that they can give you to very, very small decimal or many decimal places, a very, very small measurement. But your answer cannot be more precise than your least precise measurement. So that you need to be careful to express your answer with the proper number of significant figures. You want to do your calculations and then round up to the appropriate number of significant figures in the answer. Don't round up too soon because that can skew your results the wrong way. So go ahead and use more precise, I put precise there in quotes, more precise numbers as you're doing the calculation, but then make sure you express your answer with the correct number. Just a note, most scientists round up with the number 5 only if it makes the number that you're looking at even. So if you have 207.5 and you need to express your answer in 3 significant figures, we're going to have to round up this 7. We look at the 5 and see that the 7 is an odd number, so that would be rounded up to 208. But if the measurement was 208.5 and we had to round it to 3 significant figures, this 8 is already even, and so we would just drop the 5 and not change the 8 to a 9. This is important because when you're doing repeated measurements on the same experiment, if you always round up with a 5, you can skew the results to a slightly larger number. By only rounding up when it would make that new uncertain digit a even number, then some of the times you will round up with a 5 and some of the times you won't, and it averages out to being a more accurate result in the long run. When you're working with significant figures, you have the rules that go for addition and subtraction and the rules with multiplication and division. In addition and subtraction, your answer is rounded to the number of significant place values in the least precise measurement. Most of the time this is going to concern decimal points, so you can think of this as being the least number of decimal points. So if you add 16.7 grams and 5.24 grams, you get 21.94 grams, but there's only one decimal place in the least precise measurement, this first measurement here. So your answer would be 21.9 grams. You only have one decimal place in your final answer. Occasionally you may be working with measurements where you need to think about the place values, not the decimal place when adding and subtracting. So if we had 78,500 meters and subtracted 362 meters from it, you get 78,138 meters, but you only had significant in the place value number to the hundreds place here. The tens and the ones, those were zeros, and those are not significant zeros, and so we only have the least precise place value is the hundreds value. So we want to knock off these two numbers in the tens and the ones place value because they were not there in our least precise place value, and the answer would be 78,100 meters. That particular type of rounding is not as common in your textbook as the one concerning decimal points. In multiplication and division, your answer is rounded to the number of significant figures from whatever measurement has the lowest number to begin with. So here we've got a division problem, 37.46 grams divided by 12.7 cubic centimeters. On your calculator, you can get this wonderful, precise number going out 8 decimal places. That's a little bit too extreme. What do we have? We have 4 significant figures here. We have 3 significant figures here. Our answer then needs to have 3 significant figures. 2.9. Then we look at that last one, the 4. It needs to be rounded up because the number next to it is a 9. So we get 2.95 grams per cubic centimeters. So again, with multiplication and division, you're looking at the measurement that has the lowest number of significant figures to begin with out of all of the ones that you're working with. With addition and subtraction, you're looking for the lowest place value, which usually is the smallest number of decimal places. Remember too that any number that is a count or part of a definition, like with your dimensional analysis, when you say that there in 1 meter you have 1,000 millimeters, these are part of the definition and they don't count for significant figures. You don't have to think, oh, I only have one significant figure. You can disregard the definitions or numbers that represent a count. It's only measurements that you're concerned about significant figures. I hope you already know from your math class that scientific notation is what we use for very small or very large numbers. And it's helpful in our chemistry calculations because it will remove all non-significant zeros and make those significant numbers a little bit easier to remember. So here we have this huge number of 125 trillion. Well, it's scientific notation. We've got 1.25 times 10. So how many zeros or how many places are we moving that decimal point? We're moving it from this point over 14 spaces to the right. So it's going to be a positive number, 10 to the 14th power. In the second example, we've got a very, very small number, the decimal place way over here in front of 7 zeros. Again, we're going to write that as 3.679 times 10 to the negative 8, because we're going to be moving it 8 places to the left. So we call these forms of the numbers the expanded form, and then as compared to the scientific notation form. If you have a positive exponent in scientific notation, you have a very large number, the decimal point is going to move to the right, and if you have a negative number as the exponent, the decimal point is going to move to the left. Notice that the format is your number, we'll just say x here, and the ones place, and then the decimal point, and then however many numbers you need to finish up that, the number of significant figures, times 10 to whatever power. So you only have a ones place and then the decimal point and then the rest of your numbers. You include all of your significant zeros in the number, and remember those right end zeros are significant if there was a decimal point, and they are not significant if there was not a decimal point. So if you have a number like 5,100, and to write that in scientific notation, we'd have 5.1, but these numbers, these zeros here are not significant, so we can forget about them when we say times 10 to the third. And that then kind of solves some of the challenge of trying to figure out whether your zeros are significant or not. But if you have a measurement that would say, 517.0, this zero is significant because it's a right end zero in a number that has a decimal point. So your scientific notation there would be 5.170 times 10 to the second power. So scientific notation is helpful for figuring out which zeros are significant or not. Be sure you include them when you transfer something or translate something into scientific notation. The problems with scientific notation can be done on your phone. You don't need a scientific calculator if you remember the rules for working with exponents. So just to give you a quick review, if you're adding numbers with exponents, so we're working in scientific notation, so if we have 4 times 10 to the 6th power, and we want to add that to 5 times 10 to the 7th power, well, our bases are the same here, the 10s, but our exponents are different. We have 10 to the 6th and 10 to the 7th. Those need to be exactly the same in order for us to add. So we would change this to 4 times 10 to the 6th, keep that the same, plus we're going to make this number a 10 to the 6th number, and that would be 50 times 10 to the 6th. Now our bases and our exponents are just the same. We can then deal the addition with the numbers. So 4 can be added to 50 to give us 54, and we just carry over that 10 to the 6th power. So as long as your exponents and your bases, and since in scientific notation your base is always going to be 10, if your exponents match, you can add or subtract the numbers and then just bring that 10 to whatever exponent over. If you're multiplying, so if we're going to multiply 4 times 10 to the 6th power times 5 times 10 to the 7th, here again all we need to worry about is the bases, and base 10 in both cases with scientific notation they're the same. So we can multiply our two numbers out front to give us 20, bring the 10 over, and now when you're multiplying with exponents, if the bases are the same, you add your exponents. So 6 plus 7 is 13, or if this was division, you would subtract your exponents. So that you can do a lot of these calculations for chemistry class with the simple calculators found on a phone. You don't need to have a scientific calculator to work with scientific notation. That finishes what I wanted to talk about for calculating with significant figures and scientific notation to get you started on giving me answers in the correct form for your problems, your quizzes, and your tests.